Researchers are clearing a major hurdle in quantum computation. A photonic brain implant could change how we study and treat cerebral ailments. And a new antenna could pave the way to 6G networks. All your industry headlines are on Photonics Spectra Now. Photonics Spectra Now is brought to you by SMARACT, your partner for high precision in positioning, automation, and metrology. Visit smaract.com to learn more. And by Hamamatsu. Photon is our business. Go to hamamatsu.com for more info. This is Photonics Spectra Now, covering all the latest news and developments across the industry. I'm Joe Kaczynski, Senior Editor with Photonics Spectra. 1 week after announcing plans to sell its non-optical analog mixed signal sensor portfolio to Infineon, AMS OSRAM is releasing details on a simplified strategy which includes cutting 2,000 jobs. Half of those positions will come out of Europe. This move is one part of a plan to shift the company's focus to digital photonics, intelligent optical semiconductor emitting and sensing technologies. Another part of the shift was selling its non-optical sensor business to Infineon for roughly $670 million. Infineon gains intellectual property, assets, and about 230 employees in the deal. Efforts to boost chip production in Europe are materializing. French research organization CEA has just inaugurated the FAMES pilot line, and IMEC has inaugurated its own cleanroom expansion for Europe's Nano IC pilot line. Both projects are receiving support from the EU CHIPS Act. FAMES is backed by nearly $1 billion in investments from that act and the European Commission and France 2030. Nano IC is also receiving funding from Horizon Europe programs and from several neighboring countries. Project leaders call these initiatives a step forward for Europe's semiconductor leadership. Some big money is coming to the University of Rochester as its Laboratory for Laser Energetics is receiving $111 million from the U.S. Department of Energy's National Nuclear Administration. That money will go towards major renovations at the Omega Laser Facility, America's largest university-based DOE laser facility. University officials say the Laboratory for Laser Energetics is the cornerstone of the U.S. effort to study high-energy density physics and laser-driven fusion. Now to a trio of R&D headlines. Let's start in Stuttgart, where researchers are taking a key step towards scalable photonic quantum computation and quantum communication. Scientists from the University of Stuttgart and the Julius Maximilians Universität Würzburg, led by Professor Stephanie Bars, have demonstrated a source of single photons that combines on-demand operation with record-high photon quality in the telecommunications C-band. And it operates at a wavelength compatible with existing telecommunications infrastructure. A lack of high-quality on-demand C-band photon source has served as a bottleneck of quantum optics for more than a decade. Now that could be changing. On to Denmark now, as researchers have developed a long, needle-thin brain electrode with channels enabling both neurosignal recording and precisely targeted medication delivery across different regions of the brain. The so-called microfluidic axial trode, named for its ability to distribute functional interfaces along the length of the implant, is the result of a collaboration between the Technical University of Denmark, the University of Copenhagen, University of College London, and other institutions. Now, while this tech is primarily developed for research into the brain, it could be used in special treatments through targeted drug delivery combined with electrical or light-based stimulation of specific areas of the brain. And does 5G still feel too slow to you? Well, a new topological antenna could pave the way for 6G networks. Inspired by topological photonics, researchers from Singapore, France, and the US have designed a compact antenna that can handle data-loaded terahertz signals. In their recent work in Nature Photonics, they were even able to demonstrate frequency division demultiplexing of 3 terahertz wireless links, achieving an aggregate data rate of 72 gigabytes per second. If you want to learn more about these stories, be sure to go to photonics.com for our in-depth reporting on these advancements and complete coverage on all the biggest headlines from our industry. And before you go, be sure to give this video a like and click that subscribe button in the corner for all the latest from Photonics Spectra Now and the industry-leading All Things Photonics podcast. I'm Joe Kaczynski, and thanks for watching.